cities face intensifying heat waves and hidden environmental risks, an Indian space tech startup is changing how we see heat itself. SatLeo Labs is building what it calls a thermometer for Earth, using satellites, drones, thermal intelligence to map urban heat and invisible emissions. From detecting methane leaks in landfills to identifying cooler, safer urban pathways, its technology promises actionable climate insights from cities. Joining us today, Mr. Urmil Bakai, co-founder of SatLeo Labs, in conversation with ETV Bharat senior journalist Anubha Jain. Welcome to our channel, sir.
Thank you. Thank you for having me here.
So, sir, first I'd like to know what does your work reveal about how heat actually behaves inside a city beyond traditional averages? Tell us about your work in simple terms.
Okay, as you already mentioned in the introduction, we are a space tech startup and we are building a thermometer of planet Earth. So this thermometer is nothing but our constellation of satellites, which will be launching on low Earth orbit, and it will capture thermal imagery. Now, when we see thermal imagery, it essentially captures high resolution temperature information, which is a critical gap at this moment of time. And the way we see global warming happening across the world, like global warming is no more a word we hear in the newspapers, but it is it is getting reflected in our day-to-day lives. Temperature is the key ingredient here, and which is causing global warming to this extent. So right from this temperature putting stress on our infrastructure to around urban or our urban sprawl, the way we look at pollutants, the way we look at our heat strokes, it is affecting our daily lives, and that is the reason for you to actually get into mitigating this phenomena. It is firstly very important to identify it and quantify it at a right time and at the right point. So that is the entire mission what SatLeo Labs is all about.
Okay. So thermal maps are powerful, but cities often struggle to act. So how did thermal intelligence change problem solving, especially for cities with limited capacity? And who bears this responsibility if the data, drives costly or disruptive actions?
Yeah, to give you very simple examples, like we see people dying from heat stroke, right? So last year itself, 5 million people died of heat strokes in Europe alone, right? In India, this problem is even worse. Where we see a lot of our gig workers and laborers, working tirelessly in heat and dying from heat stroke. Simple health department of any urban local body, if they are able to identify hotspot of this heat stroke and act as around the specific areas where the chances of heat strokes are maximum, they can save lives of mankind. So a simple identification and a target based intervention can save lives. So that is the simplest way of using thermal imagery. When we look at urban planning, this data can identify green covers, can identify industries which are causing a lot of heat around our environment. Can the urban authorities can give instruction through real estate developers to increase more green cover. For example, a city like Ahmedabad, where we are supposed to have Commonwealth Games, and in future maybe Olympics is being talked about. No, if you look at it, the countries who have actually hosted Olympics have done a lot in terms of controlling the thermal comfort of the citizens and the players who are going to participate in these games, right? So those kind of interventions an urban authority will be able to act upon and improve the overall livability index of the citizens across the city.
Okay, right. So, sir, most climate solution focus on carbon. So why did SatLeo chose this heat as the primary signal, and what does it reveal that carbon accounting misses?
Yeah, so when we look at the birth of SatLeo, how did we start about this journey? No, we were actually doing a project around agriculture, where the farmers were getting a lot of insight through satellite imaging and around crop yield estimation, crop health information, and all. That's where we identified that there is a lack of temperature data which are specific to the field level interventions. That's where we actually started identifying that how can we solve this problem of not having a high resolution temperature information. And soon we could understand that temperature information is not only essential for agriculture, but it is also impacting a lot of areas around urban GHG gas emissions, as you rightly point out. And net zero is one of the biggest commitment our country as well as globally countries have been committing to the United Nations and other bodies, where we are going to so for example, Prime Minister of India has committed by 2040 India will be net zero compliant. For you to become a net zero compliant, you need to identify where all this and identify and quantify the kind of emissions we are as a country we are emitting. So that's where temperature information can also identify good amount of GHG gas emissions and actually track it to the net zero commitments as well.
Okay. So blending drone infrared with satellite thermal data is complex. What were the biggest challenges in calibration, and how confident are you in street level accuracy?
So, if you really look at our team, we are a small 25 people team at this point of time. Out of this 25, seven are ex-ISRO scientists who have worked decades, who have got decades of experience around around satellite manufacturing, payload manufacturing, worked on complex data, integrating it with various technologies and providing data sets to enterprises and government. So one, we have a deep domain understanding within the team. Secondly, the overall technology landscape is changing, right? So, if you really look at the way GIS data or any remote sensing data, any digital data, to the fact it is getting used, things are getting simpler and simpler in analyzing and giving an insight to the customer. So no more, the days are gone where a simple database is thrown to a customer, to an industry, and left it to them to get an insight. Customers are now wanting to get insights rather than getting pure data, and apply a lot of AI and machine learning algorithms. So with advent of data, this becomes a very simpler task for us. Having said that, when I say simpler, it is because of the kind of team we have and the kind of experience that they've got on the shoulders.
Mhm. So, sir, your Tumkuru pilot exposed hotspots, methane leaks. How scalable is this model for mega cities like Bangalore, Delhi, or Mumbai, or how can it reshape landfill management and emission compliance? Or I would say, how can such insights change the way Indian cities manage landfills and comply with global emission norms?
Yeah, when we started combining these technologies like satellite images, drone, as well as IoT, our ultimate objective is that this has to get into pure the output should be pure from the satellite images. But since our satellites are still not there up in the space, starting Q1 next year, the satellites will be launched. As and when our constellation of satellites increases, the kind of accuracy and the kind of scalability also increases in our area. So that's where we feel that finally the in 3 years time when we have our full constellation in place, we would be solely relying on our satellite data, which is going to be very very accurate and high resolution to the T, right? So that is where it is going to be scalable, not only for the cities but across the globe. So by the end of third year, when we'll have full constellation, we'll be able to capture high resolution temperature information twice a day for any part of the globe. So that is the kind of scale which we are aiming to achieve.
Mhm. That's wonderful. So, with TAPAS 1 and future satellites, SatLeo is building a thermometer for Earth 10 years from now. So, what transformative outcomes do you envision for climate resilience, public health, or urban planning?
Yeah, so no, to simply tell your audience and no, to a layman, the way we have Google data, like from a location A to B, you have a pure path to where from where to go. After that, you had a layer of traffic data. So that's the usability of the Google Maps or any other maps increase. And very soon you will also see a temperature layer where you will be able to see the kind of thermal comfort any citizen can actually understand and can decide which route to take. So that is the kind of ultimate aim which we have for the citizens, where the way traffic data comes very naturally to us. Temperature information or thermal comfort should come with a click of a button to each and every citizens across the globe, and whichever location geography they are residing. And that is number one. Number two, for the urban landscape, the aim is a very very precise information, and the kind of with a tune of sub 5 meter kind of a resolution. When I say 5 meter, it is every 5 meter pixel you will have a differential temperature with you. And then once you have the data, the kind of analytics, the kind of insights you derive is limitless. So that is the objective of SatLeo in coming time. And it's going to be a very disruptive technology and insight going forward.
Okay, that's wonderful, sir. So India's heat crisis is often treated episodic rather, structural. So how can continuous thermal monitoring reshape heat action plans, zoning, urban design policies, and how might health departments respond differently during extreme heat events?
Yeah, yeah. So as I said, one is right from to start from any urban planning, right? So it is like the way when you are planning your real estate, industrial as well as residential landscape. If you are able to identify the kind of heat that area generates during the day as well as during the seasons, no the urban planners can actually decide the kind of green cover around that, so that you can try and minimize the heat emissions around that area. That is number one. Number two, as I mentioned, for the health workers, once you are able to identify the areas prone to heat strokes, you are able to have a timely intervention there. No, and number three, when you have a GHG gas emission data, no, the kind of hazardous chemicals which are right now, no, and in a very interesting no use case, if you see all, especially Indian cities, you have solid waste dumps which are almost heart, which has become in the heart of the city now. Maybe around 2 decades back, this landfill, the solid waste dump area were outside the city, so that the livelihood or the people who are residing nearby to the solid waste dumps are minimal, and that doesn't affect them much. But now, with the urbanization increasing, all these solid waste dumps have actually become at the heart of the city now. And
Mhm.
that's the reason people residing across around this solid waste dumps are really affected. So that's where no, it can improve. Once you have a identification, you can actually act upon it, try to no have the no solid waste no dump mitigation plan implemented in the targeted intervention, and improve the livability no part of the citizens residing. So no, these are some of the areas which no we can change the urban planning and no urban no, areas quite much.
So, sir, can hyperlocal thermal data eventually help predict micro heat waves or landfill fires before they occur? How close is SatLeo to real-time early warning capabilities?
Yeah, so no, when you say no real time, I said our constellation is aiming twice a day kind of a temperature information, and when you put this data with the historical data as well as with a kind of AI and ML algorithms, every half an hour we'll be able to respond to a use case like forest fire or a fire prediction model. We just had some of the discussion with the Forest Survey of India as well as some of the forest departments, which are actually really grappling up with the problem of forest fire worldwide. And even in India, we don't realize, but there are small bush fires which keeps our forest department really awake at night. So that's the reason. If you SatLeo is geared up to give this hyper local micro level temperature information, not only is useful for the urban livability, but also an understanding forest fire kind of scenarios as well.
Okay, right. So,
We
lastly,
are
look,
also
please.
Yeah, we are also working on hyperspectral thermal data. So right now, our satellites will be on a dual band and multispectral kind of a mode. We are also in R&D phase on getting into hyperspectral thermal imaging, which again enhances the accuracy as well as the granularity of information available with the apart from the current data sets. So that will allow us to have more and more better resolution data, even more than the multispectral or dual band thermal information is at this point of time.
Okay, right. And lastly, sir, looking ahead, do you see thermal intelligence becoming as essential to cities as weather forecasts? And what needs to happen for Indian cities to fully adopt it?
Yeah, so as you rightly mentioned, weather forecast, is a problem at this point of time where forecasting is becoming more and more difficult because of the change in the landscape. The landscapes are changing because of global warming, the kind of emissions we are putting in the environment, and that's where more and more information like thermal information as well as the other data sets is going to improve the weather prediction model more and more. So that's where the weather prediction companies are actually waiting for a lot of data set, including the thermal high resolution temperature information and the thermal imagery, which is going to actually revolutionize the way we look at weather prediction. Some of the countries are able to have better weather prediction because of the some of the no local no IoT no sensors they've put in. But a country like India or most part of the world, it is not possible for you to put IoT sensors across the landscape, and that's why satellite imagery and satellite based solution is the only option to improve your weather prediction models.
Okay. Right, sir. Well said that landscape is changing and global warming are the reason. And I believe that your work will work on weather conditions and weather predictions in India. Thank you so much for this insightful conversation. Thanks a lot.
Thank you so much. Thank you so much, Anubhava, for having me. Thank you.